Welcome to the continuing AP podcast of section 4.9. Today's a big day because we will be balancing the redox equations. Now, I'm going to give you 7 or 8 steps to balancing these, and you really need to pay attention to all of them. Jot them down because you're going to refer to them quite a bit while you start doing this. So let me get right to it. First of all, the key of this whole thing is that it's all about the number of electrons. The number of electrons produced has to be the number of electrons that were accepted. And after that, the next thing, this is for an acidic solution. And I'll just tell you right now that most of our steps are acidic. Okay, so we've already shown you this in the last podcast, right? The half reactions. Then the very next thing you do is you're going to balance all the atoms except for H's and O's. Then you're going to balance O using water. And this is going to be a different step because you guys are used to balancing equations where we just add coefficients or subtract coefficients or do whatever with the coefficients. In redox reactions, we're actually going to add water and H and electrons. We're going to add things to the reaction. So that's going to be a little different. The next step, step 4, you're going to balance all the H's using H+. And the H+ kind of goes to the fact that this is an acidic solution. Then the most important part, well, not most important, but a very, very important part, is we're going to balance the charge using electrons. And then if the electrons are not even on both half reactions, we'll multiply both equations to do that. All right? And then we're going to add the half reactions, and then we'll check everything. So let's get right to it because these are pretty involved. And I've had people that say, boy, I really like these after a while. But it's pretty confusing at first, so just bear with me. Let's write the two half reactions first. Okay, Cl minus and Cl2. Okay, and then the other part is Cr2O7, 2 minus, and Cr3+. Now, I'm not going to go back and forth to the steps. I'm hoping that you have them written down, so just refer to them. So the first thing we do is we write the half reactions. Next, we balance all the atoms other than oxygen and hydrogen. So I've got 2 Cl there. I've got to put a 2 here. The next step is to balance oxygen and hydrogen, but notice in this half reaction we don't have that. And then the last step is to balance the charge. Well, we've got 2 negatives on this side, so we have to have 2 negatives on this side. What can we add? Well, we add 2 electrons. Okay, so there's that half. Now let's go to this other half. We've got 2 chromium, 1 chromium. Let's put a 2 there. Okay, then the next thing, balance the oxygen with water. I have 7 oxygen on this side, so that means I'm going to add 7 waters over here. All right, then the next step, balance the H's with H+. Well, notice on this side I have 14 hydrogens, so I'm going to put over here 14 H+. And then the last step is to balance the charge. Well, let's look at what we have on this side. Okay, over here I've got 14 pluses and 2 minuses for a total of plus 12, right? And on this side I've got plus 6. Okay, now I've got to get those equal. Well, the only thing I can do is add electrons. So I'm going to add electrons to the side that has the greater positive side. And so how many electrons do I need to add to get both sides to plus 6? I've got to add 6 electrons. So I'm going to go 6 electrons. Okay. Now I want you to notice where the electrons are on the 2 half reactions. They are on opposite ends, and they have to be on opposite ends, always. If they're ever on the same side, well, you messed up somewhere. Okay, so that's super important because think about it. If something's producing electrons, like this side right here, something's got to be accepting electrons on this side. All right, so there we go. Now I've got that. There's step 7 would be, actually, step 6 would be multiply the equations to make the electrons equal. Okay, well, I've got 6 electrons here, and I've got a total of 2 electrons here. So what can I multiply this whole thing by to make them equal? Well, I could put a 3, right? So that gives me 6 Cl minuses, 3 Cl2s, and 6 electrons. Okay? So there we have that. Now the next step is add the equations and cancel out identical species. So I'm going to put a line right here. Okay, look at this. 6 electrons 6 electrons. I don't have to do anything else with hydrogen or oxygen, and so I can just add this up. So this balanced redox reaction looks like this. 14H plus Cr2 O7 2 plus or 2 minus plus 6 Cl minuses yields 3 Cl2s plus 2 Cr3 plus 7 waters. Okay? Now, like always, when we think we have it done, we've got to check everything. And the easiest thing to do is to check the atoms first. So I'm going to look at these. I've got 2 chromium there, 2 chromium there, 6 Cls, 6 Cls, 14 Hs, 14 Hs, 7 Os, and 7 Os. That's good. So now we've got to check the charge. Let's look at what kind of charge we have on this side. I've got 14 minus 2 minus 6. And that gives me 6. Right? On this side, I've got 2 times plus 3, which is plus 6. All right, so the charge is balanced. So this beast is our first balanced redox reaction. Pretty awesome, isn't it? All right, pause the video and see if you can do this one. Again, we balance the atoms other than oxygen and hydrogen. So there's 2 arsenic here. There's 1 there, so I'm going to put a 2 right there. Then I'm going to balance the oxygen using water. I've got 3 oxygen on this side, and now I have, look at this, I have 8 oxygen on that side. So how many waters do I need? Hopefully you said 5. 5 waters. Okay. And then I've got to balance the hydrogen using H+. Okay, so on this side I've got 10 H's. On this side I have 6 H's. So I've got 4 H pluses. So last but not least, I've got to balance the charge here, right? Well, let's look at what we have on this side. There's no charge there, and over here we have 4 H pluses. So I'm going to have to put 4 electrons, right? Because 4 minuses and 4 pluses equals 0, and that's the kind of oxidation state we have on that side. All right, let's do the other one. NO3, there's 1 N, 1 N. Let's balance the oxygen using water. So I have 3 water here. Okay, now my O's are okay. So now I've got to balance my H's. There's 4 H's, so I'm going to put 4 H plus over here. And now I've got to balance my charge. I've got a total of, so there's 4 plus and 1 negative there, so I've got to go 3 electrons. Okay, now I've got to balance the number of electrons. Look at here, I've got 3 on this side, I've got 4 on that side. So you've got to multiply them both by each other. We've got to have kind of I guess the least common multiple. So I'm going to multiply this whole thing by 4, and I'm going to multiply this whole thing by 3. So let's do that and rewrite them in a different color. So that gives me 15 waters, 3, I don't even know what that's called, arsenic oxide, 6 H3 ASO4, 12 H plus, and 12 electrons. Okay, and then down here we've got 12 electrons, 16 H plus, 4 NO3 minus, 4 NOs, and 6 waters. Whew, can you see how involved these problems can get? But you really get a sense of accomplishment when you're done with them. So now I've got to cancel everything on opposite sides and then add them together. So let's look on this side. I've got 12 electrons on this side, 12 electrons on that side. Okay, so those are canceled. I've got 16 H's on this side and 12 on that side. So that means 12 of those are gone, and that leaves me with 4 H pluses. Right? Then I've got, over here, I've got 6 waters on this side. I've got 15 waters on that side. So those 6 waters are gone, and that leaves me with, wait a minute, did I do that? Nope, sorry. You will probably scream at the screen. There was 8 waters there. There we go. That leaves me with 7 waters. Okay? And so now that I've got that all done, I can write the new total, or the full reaction, and it looks like this. I've got 7 waters, plus 3As2O3 plus 4 H's, H plus I should say, and that, oops, plus, oh man, I hate this thing, four NO3 minus yields 4 NOs and 6 AS, oops, I'm going to have to fit it down here, 6H3 ASO4. Okay, so now we got to check everything. 3AS, 3AS. We've got 14 H's and 8 for a total of 18 H's. I've got 6 times 3, 18 H's. There's 9 O's plus 7 O's is 16 O's. Ooh, look at that. Plus, so that's 30 O's. Whew, that's a lot of O's. So 6 times 4, 24. Plus 4 is 28. Maybe I did my math wrong here. Oh, 9 and 7 is 16. 16 and 12. Oh, how about 28? There we go. Okay, so all those are balanced. Oh, 4 nitrogens, 4 nitrogens. And let's check our charge. On this side, we have no charge, right? So let's look at this. 4 H pluses, 4 NO3 minuses. So, whew, it's balanced. Now, if that doesn't give you a sense of accomplishment, I don't know what does. At least in the chemistry world. All right? So, on to the last one. We've got to do one more. All right, in a basic solution, the steps are exactly the same as before, except when it's all done at the very end, we're going to add some OH to the H's, and we're going to do that to make it a basic solution. So what I'd like you to do is go ahead and pause the video, work it all out exactly the way you've done before, and then I'll show you what to do after that step. Okay, in green there is what I've got at this point, and now we're going to do that last step. Notice it says add enough OH to both sides to neutralize the H+. Well, I've got 4 H pluses, so how many OHs do I need? Well, I need to add 4 OHs, OH minus, to both sides. Okay? And then at this point, we have to think about what's going to happen here. If I get those 4 OHs and 4 H's, what am I going to make? I'm going to make 4 waters, correct? Okay? Now, look what I have on this side. I have 2 waters on that side. So really what happens now is the 4 OHs stay there in my final reaction, but what happens is those 2 waters are now gone, and the 2 of those 4 waters are gone, so now I have 2 H2O. So I've run out of room, but imagine this reaction looks like this. Okay? 4Ag, 8Cn minus 2 waters plus O2 yields 4 silver cyanide plus 4 OHs. Right? We'll go over a lot of these in class and practice them, and you'll see that they're pretty fun when you start getting them right. Have a great day. See you next time.